Have you ever stopped to think about what a sunset might look like on another planet? I mean, really, think about it. What about a world where the sun sets, then rises, then sets again, all in the same day? Or a sunset that isn't red or orange, but a brilliant alien blue? Well, guess what? This isn't science fiction. This is real physics. So let's really dive into this, because the possibilities are just staggering. We are going to go on a tour to witness some of the most beautiful and, frankly, deadly alien sunsets the universe has to offer. And just to give you a sense of the scale we're talking about, look at this number, 100 billion. That's a rough estimate of how many planets are in our Milky Way galaxy alone. I mean, some of them orbit two stars, some orbit dead stars, and yeah, some might even orbit black holes. The universe is a really strange place, and the view, well, it's about to get spectacular. First up, let's start with a tour of our own solar system. You'll see that even with our familiar sun, some of the planets we think we know can create some truly alien skies. So, our tour begins right here, in our cosmic backyard, the rocky inner worlds. You might think their sunsets would be kind of familiar, but trust me, they're already far from ordinary. First up, Mercury. On Mercury, there's basically no atmosphere to scatter light, so you don't get those beautiful twilight colors. The sky is just always black. But don't you worry, Mercury makes up for it with a different and much, much weirder spectacle. That's right, a double sunset. It's all because Mercury has this weird oval-shaped orbit. At certain points, the planet actually zips around the sun faster than it spins on its own axis. So from the surface, you get this bizarre illusion where the sun starts to set, then stops, rises again for a bit, and then finally sets for good. It's an incredible sight that only happens once every 176 Earth days. Next stop is Venus, and here you don't even get to see the sun. Not as a disk, anyway. The atmosphere is just so incredibly thick with clouds of sulfuric acid that it's completely hidden. So instead of a setting sun, you'd watch the entire sky shift from this hazy yellow glow to a deep, dark red before it all just fades into a starless, pitch-black night. And if you want to see the show, you better pack your patience. A single day-night cycle on Venus, we're talking one sunrise to the next, lasts a staggering 116 Earth days. That means the sunset isn't some quick event. It's this slow, gradual spectacle that would literally stretch on for days. Okay, our next stop, Mars, is famous for a sunset that completely flips our expectations of color. And the reason why all comes down to a special kind of physics. See, unlike on Earth, the key isn't the air itself, but all the fine dust floating in it. It's all because of a principle called Mie scattering. And this chart shows the difference perfectly. Here on Earth, our thick atmosphere scatters blue light away from our line of sight, which is why we're left with all those beautiful reds and oranges. But on Mars, it's a totally different story. The thin air is filled with fine, iron-rich dust. Thanks to Mie scattering, these dust particles act like tiny mirrors, beaming blue light forward, right towards you as you look at the setting sun. And the result is one of the most iconic sights in the solar system, a stunning, beautiful blue sunset. All right, leaving the inner worlds behind, our journey now takes us out to the realm of the gas giants. Now, you can't exactly stand on their surfaces, but the views from their upper atmospheres, and especially from their dozens of dazzling moons, are just breathtaking. Imagine you're floating at the very top of Jupiter's clouds. The sky around you would be a blue that's deeper and darker than our deepest oceans. And the sun? It would look like a tiny, incredibly bright button, just a fifth of the size we're used to seeing from Earth. But Jupiter's real spectacle isn't about color or illusion. It's about pure, raw speed. This massive planet completes a full spin in just under 10 hours. Think about that. If you spent one Earth day there, you'd get to see 2.5 sunrises and sunsets. It's a cosmic light show stuck on fast forward. And the moons, they offer even more variety. On volcanic Io, every single sunset is a 2-hour-long total solar eclipse as Jupiter just blocks out the sun. Over on icy Europa, the sunset actually triggers this ghostly glow as radiation makes the surface ice shimmer. On Ganymede, you'd get auroras, though you'd need some special gear to see them. And on distant Callisto, these eclipses are a rare treat, happening only about once every 3 years. From the many wonders of Jupiter, we move on to the absolute jewel of our solar system, Saturn.
From its cloud tops, the setting sun is beautiful, sure, but it's not the main event. No, the real show is the rings. You'd get to watch the massive shadow of the planet itself creep across that brilliant arch, extinguishing the reflected light section by section. It would be like watching the lights go out on the grandest structure in our entire solar system.
All right, let's journey even further out to where the ice giants live. Out here in the cold and the distant darkness, our concepts of time and light get stretched to their absolute limits.
You want to talk about a long day? Let's talk about Uranus. It's tilted so far on its side that it basically rolls around the sun. So if you were standing at one of its poles, you'd have to wait 42 Earth years for the sun to finally set. 42 years!
But I'll tell you what, when that sunset finally arrives, it's gorgeous. The atmosphere is full of methane, and methane is really good at absorbing red light. So as the sun dips below the horizon, the sky doesn't turn red or orange. Instead, it fades from this brilliant cyan color to a deep, cold turquoise. And for a brief final stop in our solar system, let's just pop over to Pluto. It's incredibly dim this far out. The sunset would reveal a very, very dark blue sky, and its largest moon, Charon, would just be hanging there, motionless in the same spot forever.
Okay, it is time. We're leaving our planetary neighborhood behind. The sunsets we're about to see are on planets orbiting other stars, and some of the most extreme objects the universe could possibly throw at us.
So check this out. This is a planet nicknamed Poltergeist, and it orbits a pulsar. That's the super dense, rapidly spinning core left behind after a massive star dies. This tiny dead star acts like a cosmic lighthouse, flashing a beam of radiation 161 times every single second. From the planet, the sunset would be this absolutely mind-bending strobe effect as this blindingly bright object dips below the horizon. But for the most extreme sunset imaginable, we have to go visit a planet orbiting a supermassive black hole. I mean, the scale of these things is almost impossible to comprehend. Holmberg 15A has the mass of 22 billion suns, and they only get bigger from there. Here, the sunset isn't a star dipping below the horizon. It's the black hole itself, a perfect circle of pure blackness against the warped, gravitationally lensed sky, eclipsing the entire galaxy behind it. Now, we need to be clear here. Scientists believe it's totally possible, theoretically, for planets to have stable orbits around black holes, but we haven't actually found one yet. The areas around them are just so chaotic, and our current planet hunting methods just aren't quite up to the task. It's one of the great observational challenges we still have to solve. From a double sunset on Mercury, to a blue glow on Mars, all the way to a theoretical light show at the very edge of a black hole, our universe is just filled with spectacular sights. It really makes you wonder, right? What else is out there just waiting for us to find it?